Hi everybody, my name is Brice Bucher. I'm the Senior Manager of Products here at Flexware Innovation. Today we're going to be talking about intralogistics. And specifically we're going to be talking about the problems that can occur as companies start to introduce automation and emerging technology into their intralogistics space. So let's start with some definitions. So first of all, when we talk about intralogistics, we're talking about the movement of materials within the four walls of a facility. So I've got my makeshift facility here. We're going to be ignoring all the other things that happen in the supply chain outside of the facility. And secondly, we're going to be introducing a very simple model here. Flexware, we love models. Who doesn't like models? Models allow you a way to persist information. It gives you a way to be able to kind of create a sticky situation or a reference that you can talk to over and over again. And they tend to have a way of creating a foundation for a communication around something that otherwise might be kind of nuanced and complex. So our model is going to be a matrix, and across the columns of our matrix are going to be the processes that exist within our facility, and the rows of our matrix are going to be the systems. And for the purposes of this exercise, we're going to be talking about a typical manufacturing location. Flexware does most of its business with manufacturers, so we're going to talk through the processes for manufacturing, but this could just as easily apply to warehousing or distribution industries as well. The names in the boxes are going to change a little bit, but otherwise everything is going to hold. So I'm going to start by kind of laying out some of the processes that exist. And typically within manufacturing, you have three main process areas. And that is receiving. Then you have your main manufacturing process. And then finally you have shipping. So in this model, we're representing kind of the flow of materials through your facility. So you've got all your incoming raw materials flowing into receiving, being processed, made into finished goods, and then finally shipped out through the shipping department. So I'm going to take a few minutes here. I'm going to lay out some of the sub-processes that exist within each of these main process areas, and then we'll reconvene and we'll talk through some of those before we move on to the next part. Okay, so we've got some of the sub-processes defined here. And let's talk through real quickly at a high level what we're talking about here. So receiving tends to be a pretty straightforward process when it comes to manufacturing. You have your truck unload process where you get your raw materials off of the trucks. You always put them away typically in some sort of a warehouse, whether it be bin locations, high bay storage, racks, you name it, depending on the type of material you're moving and the type of container it's in, it could vary. And then at some point in time when you need those materials to be brought out to manufacturing, you've got to do a pick from that warehouse location, and then you stage it for delivery out to the manufacturing area. And in some cases, you've got a kitting operation where you're taking multiple materials and you're pulling them together into a common handling unit or container for delivery out to the manufacturing as well. So fairly straightforward process there. Most of the complexity kind of happens out in manufacturing. And for the most part, all the movement is happening through very simple point-to-point picks and drops, where you're picking originally from your staging locations in the warehouse and you're pulling them out to in-feed locations out in your manufacturing area. And then as your sub-assemblies and components are getting made, you're picking from the outfeed of those pieces of equipment and then you're delivering to the downstream pieces of equipment. Eventually you've got finished goods coming out of that you need to deliver into your shipping warehouse. But as far as the places that you're picking and dropping from in manufacturing, you really kind of have three main categories. You've got just general locations, which could be just areas on the floor where you're dropping a pallet of something, or it could be some simple rack or stand that you're putting something on top of. but you also might be delivering to actual manufacturing equipment or machines. You might have conveyors or robot cells or something that have an in-feed to them that you need to be able to handshake with and communicate with to drop that material. And then finally, the most complex one are these work in process or WIP buffer areas that exist out in manufacturing. These tend to exist because you might have a bottleneck in your process, and that bottleneck might be, if that bottleneck happens to go down, you're starving some of your later processes, so you need to build a buffer so that those downstream processes can continue to function when your bottleneck goes down. So these WIP and buffer areas, they could be, again, just like a matrix of locations on the floor. It could be some racking system, but there's a lot of movement and turnover of inventories that's been moved in and out of those buffer areas. Okay, so once you get your finished goods manufactured, they need to be shipped out, of course, and in some cases you might ship those directly onto a truck and out the door. But in most cases, you're putting those away as well into some sort of a warehouse environment. Again, that could be some high bay storage racking system. It could be floor locations. You might have more equipment involved in the shipping process because you need to palletize things. Maybe you need to scan things and co-palletize things together. So there could be some more conveyor equipment, things like that involved. But eventually you're going to be picking your final load and you're going to be loading that onto a truck. So in general, that's the process most manufacturers go through. So if those are the processes, let's talk a little bit about the systems that are involved in making all of those processes happen. So at Flexware, we tend to like to use the ISA 95 model to depict the hierarchy of systems that are involved within manufacturing. So I'm going to kind of borrow from that a little bit. I'm going to tweak it just a little bit for intralogistics, but I think it works well for hammering our point home here. So you tend to have 5 levels involved in the ISA 95 model. And at the top level, level 4, all the way down to level 0. So level 4 is what we call the ERP layer, which tends to have all of your higher level financial and business systems in it. The next layer down, I'm going to term this your operational management level. A lot of times in manufacturing, we call that your MES layer or your MOM layer. But I think because we're talking about intralogistics processes here, I'm just going to settle on this term operational management. So these are still higher level systems, but now we're starting to be much more centric towards the production area that those systems are managing. So this is taking information like high level schedules, bill of materials and things out of your ERP and transforming them into a way that they can be used in whatever process area that you're in. Then we go down to the next layer, layer 2, which I'm going to call the SCADA layer, supervisory control and data acquisition. It's more of a supervisory level, and it's sort of the bridge between your higher level systems and your lower level systems. So kind of think about this as, at this level, you've got some sort of user interface, but it's typically being operated on by the operators of the equipment as a way to control that equipment. Also, there's some connectivity from there up into your higher level systems as well. So we go down to the next layer. This is what we call our control layer. So there's a lot of sort of behind the scenes systems here, control systems that are actually operating your pieces of equipment down to lower levels, and a connection up into your SCADA layer. And then finally, layer 0, I'm going to call this the resource level. Typically, it's for your sensors and other devices that connect up into your systems. And that kind of holds here as well. But also, since we're talking about intralogistics, I'm going to refer to this as resources because these are the devices and machines and vehicles that are actually being used to move material around. And because there's a fairly wide variety of those across your entire operation, I think it's good to kind of denote what those different things are down here. So I'm going to call this resources. And again, these are like vehicles and machines. Okay. So I'm going to take a few minutes and fill some of this in with a hypothetical set of systems that might be used to implement these processes, and then we'll come back together and talk through that. Okay, so this is a lot to take in here, but we've kind of filled in all of the systems that may be involved. Let's talk through just kind of at a high level. We're not going to spend a lot of time diving into details here, but I'm just trying to illustrate a point with how complex this can become. So typically what you have up at your ERP level is you do have a common ERP that kind of transcends your entire operation. This is where everything kind of culminates and comes together into a single layer. Very rarely do you see any operations that have multiple types of ERPs involved within a single site. So we're going to skip right down to the operational management layer here, where we're starting to see more systems introduced. So MES is a category of system that's been around for a couple of decades now, so most people are familiar with that. So we're taking schedules, bill of materials, things from the planning side of your ERP, and we're starting to turn those into real executable things down within your equipment. So all the planning and execution and monitoring of your production systems tends to happen within some sort of an MES system. It could be an off-the-shelf system. It could be a homegrown system. It may not even have a name within a facility, but it is still something that exists from a concept standpoint. WMS is a little bit of a newer term, and typically we see more WMSs in warehouse operations, but we're starting to see more WMSs pop up now within manufacturing as well. It's sort of an extension of an ERP in that it helps you manage inventory. Typically kind of stays within the warehousing parts of your operation, but it can start to bleed over into manufacturing, especially if you're doing inventory move transport orders or transactions across your entire operation. You may be reporting those back into a WMS. But for the purposes of this discussion, we're going to kind of keep the WMS in the warehouse side and the MES controlling the manufacturing side. As we go down into your SCADA layer, there's typically not a lot of complexity within your receiving and your shipping side of things, within manufacturing at least, but you might have what's defined as a warehouse execution system. More likely you have some way of dispatching orders to drivers of fork trucks or reach trucks in order to be able to direct them on how to do their putaways or their picks. And if you are starting to introduce autonomous vehicles, you most likely will have some sort of a vehicle management system, or otherwise known as a fleet management system, for those vehicles as well. As we go across into manufacturing, again, if you're implementing AGVs and AMRs, you're going to most likely have a fleet manager, because you need something that has a user interface to it that allows you to see your map, create all the routes for all your vehicles. It manages all the vehicles. It dispatches orders down to those vehicles, and it knows where all the vehicles are and how best to coordinate all of that movement. And then there's an HMI and a SCADA layer as well here within manufacturing. So this is all of the different operator user interfaces you have out there, whether it be talking to equipment, talking to third-party systems, etc. All of these operator interfaces. Okay, as we move down into the control layer, again, not a lot of complexity there when it comes to the shipping and receiving side. You might have what's defined as a warehouse control system. A lot of times that's associated with like an ASRS, where you're doing automatic storage and retrieval. But in some cases that may not exist at all, because you're just dispatching things out to humans who are driving fork trucks around. But if you do have AGVs or AMRs in your warehouse, you're going to have a vehicle control system that's going to be present on those vehicles. So this is all the sensors and scanners that are on the vehicle itself, that's making sure it operates safely and that it is able to orient itself and get where it's going. Over in the manufacturing side, again, you're going to have a vehicle control system if you're implementing AGVs and AMRs. You're going to have a lot of what's called PLCs, programmable logic controllers. Those are communicating up to all of your user interfaces that the operators are working with, and they're controlling all of the equipment that you have down in manufacturing. And when it comes to intralogistics, that could be a hodgepodge of things. It could be conveyors, it could be robot cells, because you've got these in-feed and these out-feed portions of your equipment that you're either feeding materials into or you're picking materials out of. You might have to go through doors and elevators and other things as you're executing your missions. Those are most likely controlled by some system, and you may have to interact with that particular system. On the shipping side, as we mentioned, things might be a little bit more complex because you might have sortation conveyors and palletizers and things involved, in which case you're most likely going to have some sort of a warehouse control system and warehouse execution system involved. And you have got all the same fork trucks and reach trucks and things most likely involved there as well, which are, again, human operated. So one of the things to point out here is that down here at this resource level, you've got this mixture of machines that are automated and vehicles that are human operated. So most likely, you're not a fully automated operation. So you've got this symphony of orchestration that has to happen across your entire process that includes both humans and machines. Okay, so why does this matter? Why is this potentially a problem? We're introducing automation. It should make our life more simple. So I'm going to attempt to kind of go through a use case that illustrates why this can introduce more complexity into your operation and could lead to some potential problems. So let's take a fairly simple use case where we've got, we're going to be picking a material from a staging location in a receiving area, and we're going to be delivering it to a machine out on the shop floor. And we're doing a proof of concept. If this works, we want to make sure we roll out more vehicles to do this for all of our materials, but we're going to start just with a very simple use case. We're going to pick one type of material and we're going to deliver it to just one machine. That seems pretty straightforward. It seems like a point-to-point move. It seems like all I'm really going to need, if I'm going to automate that, is I'm going to need to select an AGV. That AGV is going to have a vehicle control system on it, and most likely is also going to have this vehicle management system. This may not be necessary for one vehicle, but as soon as you get more than one vehicle in your fleet, you're going to need something that's going to be able to direct and orchestrate those vehicles. So this is going to come as part of your package that you're purchasing, and you may think you're done. But this is really where the complexity actually starts. So if you kind of start to think through, from a human-centric standpoint, what I'm going to want this system to do, and what decisions am I going to want it to make? Well, I want to be able to pick up from my staging location, and I want to be able to drop at my machine. And how do I want to trigger this mission? Well, I want my MES system to be able to trigger this, because the MES system is monitoring the production of the machine that I'm delivering to. It knows when it's out of parts. It knows what the next part is per the bill of material. It should have everything I need to know to be able to trigger this mission. So I need to be able to communicate with that MES. But it doesn't work 100% of the time, because there are exception cases where I may want to be able to trigger a mission manually, whether it be something got scrapped unexpectedly. Maybe I'm experiencing some sort of a shorter changeover because I had to change schedules around a little bit, so I need a part sooner than I otherwise would need it. So I need an operator to be able to manually trigger this as well. So I'm going to have to modify my HMI or my SCADA system to allow that operator to be able to call for a vehicle as well. Okay, so that HMI or SCADA most likely communicates with a PLC. MES also communicates potentially with the PLC. I have an in-feed for this machine. I've got to do a handshake with this machine because I have to know that there's space there for the new load to come in, and I have to be able to acknowledge back to the AGV that the handoff has happened safely and completely before it can release it back to the fleet. So I need to communicate with the conveyor that's at the in-feed of this machine as well. And oh, by the way, in between my warehouse and my machine, I have to go through a door that right now is manually opened and closed by operators from a fork truck when they scan their badge. So I need some other way for my AGV to be able to open that door. So hopefully this starts to illustrate the point that as you're introducing automation, we've acknowledged 5 or 6 different systems we're going to have to be able to communicate with in order to be able to effectively complete just this one simple use case. So when you kind of take the 10,000 foot view here, what is the thing that's leading to my potential problems here? Well, it's the fact that I have disconnected systems and I have complex processes. And the fact that these two exist are creating all these gaps within my processes and within my systems. And the more of those gaps that I have, the more difficult it's going to be to automate any particular part of this process. So what do we do about this? Well, Flexware's stance is that if you have the right middleware that's designed in the right way, you can start to integrate these disconnected systems, and you can start to simplify your processes. The integration part, it's pretty straightforward. I think we all get that. You got systems that don't talk to each other. You need them to talk to each other, right? You need to connect them and integrate them. The simplification of processes, a little bit more abstract, a little bit harder to get our mind around, but really what we're talking about here is allowing a means by which you can configure all of your use cases to perform this advanced level business logic, but to do it in a way that doesn't require a computer science degree or advanced engineering in order to make it happen. And you don't want to reinvent the wheel over and over again. We went through one simple use case. There could be dozens of those within your facility. If you have one tool that allows you to be able to set up and manage this and then scale that across your organization, you're well on your way to receiving the value that you're looking for. And then if you get that system in place and you start interconnecting your processes and your systems and you're narrowing those gaps between the two, then you start to be able to unlock hidden ROI and value that you didn't even know existed. Those are all topics we're going to get into in future videos, but we're going to leave it there for now. Thanks for joining. See you next time.